Right, well, thank you all for sticking by, the projector and me and the laptop all trying to fight each other. So I've made this talk to be a fairly quick primer to radio grounding, so it shouldn't be too long or too in-depth. But it's mainly if you're thinking about fitting any mobile radios or mobile stations. A tiny bit of what I've been through and just some caveats to watch out for. Things to do, things not to do. Things I'm sure will make Richard frown as an ex-man of expertise in the area. I did forget the wireless mouse, so afraid I'll be slightly off camera. So we'll go through the basics. Grounding is just as important as your feed line. It needs to go back somehow via somewhere. So you can sort of think about it as perhaps having two feed lines, but your grounding is an incredibly important part of any station, especially mobile stations, because you're typically using less efficient antennas or shorter antennas that rely on a really good ground coupling to get quite a lot of the work done. And they will find a ground, and they will find a ground through many, many places. And the more modern your vehicle is, the more computers will be inside of it, and the more ground paths your RF will find, and the more flashing lights you'll get on the dashboard. But you can make it from more stuff. You can make it from braiding. We'll get onto that in a minute. You can use coaxial cable. There is an asterisk for a reason on that one. And there's a really easy way of setting up a horrible ground loop, which I did quite a while ago. But you get some really interesting effects, especially on the ICOM and the older ICOM radios. Good chassis connection is ideal. I know that sounds obvious, but there are some caveats to doing that and maintaining a good chassis connection. And be very, very aware, excuse me, of galvanic corrosion. It will sneak up on you, and much like rust, it's waiting for you in the background, and you will only find it when it is either too late to do anything about it, or where you need it desperately to work and it doesn't. Rust again, always waiting for you, like galvanic corrosion. So your ground bonding options, there are a few options, but I'll run through them pretty quickly. You've got braid, wire, coaxial cable. Those are the three things. I have, experimenting on a bit of a pinch, used tinfoil, which kind of works all right, actually. And emergency blankets work quite well, but only as a ground plane. But not recommended, really, for driving with them attached to your vehicle for obvious reasons. Braid, I'll start off with first. Braid is my go-to, really, for a lot of grounding applications. It's got a really big surface area, which is what we're wanting when we're making an RF ground, to take advantage of the skin effect. So it's flexible, it's cheap, it's available in a variety of lengths and materials, as you can see there, and a variety of thicknesses. So when I'm referring to braid, that's the stuff. It's also called earth strapping, depending where you get it from. Loads of outlets do it, your regular tool shops, online merchants, marketplaces. You'll find it sometimes on sales, tabletop sales and other things like that. You can recycle it depending on what profession you're in. Sometimes they'll be using it for earthing cabinet doors and other things. It carries RF really well because of the skin effect. If you imagine braid is essentially if you've taken the inner out of a coax cable and taken the sheathing off, and the outer braid, as it's known obviously on the coax cable, you just press it flat together. And often when you get this earthing braid, if you get it, you can get it in a roll, and you can open it up. And I'm pretty sure they use the same machinery as they do for making the braid on the outside of the coax, and then they squash it flat. So you can make your own if you've got some coax lying about. A couple of eyelet crimps, you take the braid out of the outside of the coax, you roll it over something like a bit of piping or a pencil just to flatten it out nicely. And you got yourself some braid. So it's pretty well available, actually. Different materials for different needs. We'll get sort of into that in a moment or two. But of course, you've got the usual materials. You've got your tin-coated copper. Some braids will be stainless steel, typically for harsher environments, maybe marine applications. You'll get copper, sort of pure copper. You'll get aluminium as well, which is a really awkward one. I really do suggest you avoid aluminium braiding. It works, just not for very long. Nice and flexible, so it's a really good thick conductor, but it's still nice and flexible. What you'll tend to find with a lot of, especially solid core wire or a lot of wires, is that they'll break after you repeatedly stress them. So copper work hardens really quickly, as does aluminium. So anything in door jambs, boot lids, bonnets, anything like that, it will work harden and it will snap quite rapidly, actually, especially depending on the environment that it's in. Comes in a variety of lengths. As I say, you can get it on a roll. You can buy it like a 10-meter roll. You can get it pre-crimped with about 200 millimeters, 100 millimeters. It's really readily available stuff. It's used in the industry all the time. Used in hinged applications, as I've just said, because it's nice and flexible. You've got the two eyelets, so you can bolt it onto your hinges, and then as the hinges operate, the braid flexes with it. It will fray or can fray over time. So this depends on how you've made the braid. If you've made it yourself and you put it into a little eyelet crimp, where it goes into the crimp, it can work harden. So it is good to put a bit of heat shrink over, just as a minor bit of strain relief, not anything major. It's also worth noting that it will oxidize as well. So depending on what braid you get, aluminium, that'll oxidize quite readily. Copper can oxidize as well, but the oxidation will slowly eat through it. It'll become brittle and it'll work harden a lot quicker. So my usual recommendation is like a tin-coated copper braid. It's got good corrosion resistance, it's got good flexibility, and it's not too dissimilar depending on where you're putting it on your vehicle. Not suitable for weather sealing, so I wasn't sure on the name of it. I completely forgotten the time. So by weather sealing, it's the reference to like the rubber seal that you get around your car doors, your bonnet, your boot, things like that, that keeps the water out when your doors are closed. Or is meant to. I don't know if anybody here owns a Land Rover. No, that's good. Okay, you won't find out in person then. Yeah. So wire, everyone's seen wire, everyone's used wire. We use wire all the time. We've got wire on the roof for the antenna. You all know what wire looks like. There's a picture of wire for those who have forgotten. Great stuff. Comes again in a variety of flavours and colours and everything else. Many different types. Aluminium wire. Just don't. So aluminium wire came about when the copper prices went up quite high, and someone says, well, aluminium's actually pretty conductive and it's a lot cheaper than copper, so we'll make aluminium wire. And there was a while in Australia, for a while, there were a few electrical fires, and as it turned out that when you're using aluminium wire, and the regulations, you look at your wire and you say, I need 1 square millimetre for this amount of current. Your aluminium wire needs to be derated, so you'll need aluminium wire that's thicker than 1 square millimetre because it's not quite as conductive as copper, and it heats up more. Whole thing about aluminium wire, but essentially the aluminium wire was there because it's cheaper. It's also more brittle, less conductive, and can be an absolute pig to solder to. So if you have aluminium wire, don't use it. But it comes in aluminium. Copper, we've all seen copper wire, readily available. Tinned copper wire, that'll come with a layer of tin on it, as the name suggests. Really nice to solder to, you get the benefits of copper, fairly flexible, corrosion... I say corrosion resistant, nowhere near as corrosion resistant as stainless steels, but it still offers you a little bit more corrosion resistance than copper, which does oxidize really quickly when you're out and about. And it's available in reels. It's available in small lengths from various outlets. It can be recycled from a number of things. You can use wire from extension leads. Unplug them first, please, but you can use wire from extension leads. It is flexible, again with a caveat. Some really thick wire isn't. Solid core wire is definitely not for repeated flexing. If you have something you need to ground and it's never going to move, then solid core wire, absolutely fine, no problem. Can be beneficial because it does keep its shape. So when it bends around corners, and it won't get trapped. But it really isn't meant for flexing applications. Cheap. I say cheap because it's everywhere. You can pull it out of all sorts of stuff if you're throwing things away. You can keep scrap bits of wire. You can find reels on various second-hand auction sites. Quite cheap. You can use any number of it. Battery wire is a specific wire which is a really thick gauge but has really, really small strands, and a lot of them. It's incredibly flexible and it's nice and easy to solder to. If you're going to use wire for grounding, that's the wire I recommend. Battery wire. It's also got a really nice thick insulation on it as well, so it's mechanically it's a little bit more resistant to rubbing on chassis, which is another thing you sort of got to watch out for. Coloured. I put that out there. It is helpful to colour code your wire, especially your grounding straps and grounding wires. Sometimes it's helpful to differentiate between what your DC ground is and what your RF ground wires are. So you can use a slightly different colour for your RF ground, purple, for example. I do tend to say, depending on the application of grounding, in this case it's mobile grounding, so it's not too much to worry about. But I do say try and avoid mains wiring colours, blue and brown, because if you have an installation set up, it does get a little bit confusing or concerning if it's maybe in like a club shack, somebody else comes in and sees a load of what looks like live wires hanging around it. It's a bit difficult to explain. Comes in a variety of gauges. That's just essentially what thickness of the wire it is. It is prone to breaking, so repeated flex applications, it's not great for things like door hinges, boot hinges, lids, wing mirrors, that sort of stuff. E-insulation is an interesting one to watch out for. A lot of wiring, the insulation is only good to about plus 60 degrees for PVC, plus 70. And that's when it gets really soft, the insulation. And what you'll find, if it's in any trap points, the insulation will it'll get stretched and stretched. If you imagine like dough on a chopping board, and you stretch it enough and eventually you work through to the chopping board. The same thing happens with wiring insulation if you're not careful. Rather than be cut by pinch points, it'll just be slowly sort of abraded away and moved. That can be a bit of a problem because issues like that, where you have it's kind of a soft short, where it's not fully in contact with the ground, and what you'll find is the SWR on your radio will be fine, and then all of a sudden it'll go mad, and then it'll be fine again. And it's really difficult to track down, especially if you've sort of routed your wiring along on the inside of the vehicle. Stranded is always preferred. Again, solid is only for applications where it's not going to move. Coaxial cable. This is my second favourite after braid for a number of reasons. It's fairly cheap, RG58, 316. The standard rule of thumb that I keep to is whatever I've used for my feed line, I'll use for my grounding straps. Again, comes in a variety of sizes. We've all seen it. You can get really nice looking heliacs, but if you try to shove coax like that through a door, you're not going to have much luck. 316 is great. It's small, it's a thin gauge, it'll carry plenty of RF for you. And if you're using it for ground strapping, it does go through the weather sealing on doors quite nice. What I usually recommend for that is you leave a loop, so it goes down and then it goes up and then through the weather seal. And then any water that's on it goes to the bottom of the loop and then it drips off. Otherwise, you can fire, it'll run water down the coax through the door seal and then into, whatever's on the inside of the car. And usually you don't find out about that until much later in time when it's far too late to do anything about corroded connectors and bodywork. And it can handle high voltages. If all else goes wrong, it'll handle 100 watts. Flexible, some of it is very flexible, which again makes it excellent for a variety of grounding applications, especially again on bonnets and doors. And you can leave it in the elements. Some coax is meant to do that. Other coax, they suggest you kind of keep it out of the way of the ground and things. But for the most point, any sort of RG58 coax you can get is fairly tough for the elements. You're not going to do much damage. I inspect mine fairly regularly, and the insulation's still holding up. The only thing that you might have to do now and again is just check where it joins in with the crimps. That isn't work hardening and starting to split off. But a bit of heat shrink usually helps with that. Some caveats, be careful of low quality shielding. Some cheap coax has awful shielding on it, and then that will make an awful ground. Big gaps in the shielding, barely any of it's there on the braid. Things to avoid, anything to do with television or satellite cable. Anything with a polyethylene insulator, so that's like the foam insulator on it. Usually, and again, solid core, you can get solid core coax. Don't use solid core. Well, there we go. Don't use solid core. And it does have somewhat of a limited bending radius. It's not, you can't sort of crush it into a V like you can with braid. Coax doesn't tend to go that far without crushing it. There is a caveat. So coax back to ground might cause a ground loop. I'll get onto that in just a moment. So if we all remember, coax is the inner, then you have the braid. Technically, it's three. You've got the outer of the braid, you've got the inner of the braid, and then you've got the core. Because it's not going to be balanced in this situation. So in my setup, and the one that worked for me and eliminated the terrible ground feedback that I had, so I have 706 Mark II G. I don't think the name gets much longer than that. And it uses a Cat6 network cable to communicate between the head and the radio. So the radio's in the boot, the head's in a 3D printed mount just above where the dome light usually is in your car. And every time I keyed up more than 10 watts, everything was grounded, all the strapping was in there, the SWR was fine, everything looked fine on a vector network analyzer. Keyed up anything more than 10 watts, and it would start to do very odd things. So it'd either shut down, or it would bring in the preamp, or it would change frequency of its own accord. Massive amounts of RF feedback, but I couldn't understand it at the time. So ground loops, please forgive the terrible diagram. It's the MS Paint's finest. So what we've got there is essentially a bit of a ground loop. And what you'll find is that the path along this braid is going to have less resistance than the path in the middle. And what you might find is when you key up, you've actually, between this antenna support here, is walking in front of the camera, and the vehicle roof, you might have a differential in voltage, and you might find that this is actually 0.1 of a volt higher in differential than that one, whether it's because it's raining or you've got some extra fastening on it or whatever's happening. So what you find is you actually make yourself a nice little loop, and depending on the length of that RG58, when you transmit, you make yourself a handy little antenna, just right for firing RF right back in at the car. So instead, it's recommended, and this is the same for any shielded cable, is only connect the shield to ground at one end. So that's what I did. I changed it from what was on previously, like so, and all I did, if you notice, is I just snipped that bit off where I connected it to the braid. And it was fine after that, no problem whatsoever. So if you're using RG58, to get the most out of it, you connect the braid and the centre together, but only at one end. Typically, I'd suggest whichever end is closest to your radio equipment. Bond everything as much as you can, absolutely everything. It doesn't take long to do it once you've got yourself set up. Bit of a socket, you can take a screw out one of the door hinges, put your braid on, happy days. Hinges make bad conductors, they will conduct. If you get yourself a multimeter on continuity testing and you poke different places in your car, hopefully not a new car where you're poking holes in the paint, right? But you'll find it does conduct. You'll get the beep every time that you do it. However, when you start getting higher and higher in frequency, you get very weird things happening. So even if you have a few ohms resistance, that's still a problem at RF. You're still going to end up with a grounding issue. Painted metal on metal makes capacitive grounding. So here's an interesting one. You might find that you have major problems on 2 meters, and you key up to a GB3 HD on 77, and so all of a sudden everything works fine. And usually you've got quite a large part of your vehicle that's connected to something else, like your bonnet, for example, hinges. They've been painted, then they've been put on the car. And what you find is because it's a capacitive coupling, your capacitive reactance is lower on 77, so ground's good. Key up on 2 meters, you get a much higher capacitive reactance, and all of a sudden your RF impedance is off the scale. So painted metal on metal makes capacitive grounding. It can be good. Most of the time it's terrible. Drilling into bodywork, it goes without saying, avoid where possible. You are permanently modifying something, especially if you have corrosion guarantees on your vehicle. A lot of vehicles come with 10-year or 5-year corrosion guarantees, and they are difficult enough to try and get them to either pay out or repair under corrosion guarantees. You need a lot of paperwork to do it. If they're walking around the vehicle and they see a dirty big screw screwed into the side of your door frame, the first thing they're going to do is throw you off the lot. Be very aware of galvanic corrosion. That's the fun one. So you can think, I've got a good connection here, it's nowhere near water, I'm safe. Not the case. Apply grease or primer and paint over your connections if they are external on the vehicle. Yes. That's mainly to protect it from oxidation. Things will still oxidize, you'll still get a slow degrade in your grounding. It just gives it a bit of longevity. That's especially important if you're using things like screws. Normally what I'd recommend is if you have screwed into it is to apply something like a lanolin or quite a thick grease over the screw rather than paint. If you end up with a pinhole in the paint or a tiny bit of the paint as you go over the corner of the screw isn't applied properly, you'll get water on the inside of it and it'll corrode from the inside out. Because it's painted, you won't notice until it's too late and you have a dirty great hole in the side of your chassis. Galvanic corrosion is a bit of a sod. Occurs when two dissimilar metals meet. Essentially, you are making a battery. it will begin to corrode the connector or the bodywork. Now, it depends on whether or not it's the anode or the cathode. It's very much accelerated in wet environments. Normally, it wouldn't be much of a problem if you lived in the desert, but as we clearly don't, and we are wet quite a lot of the time. Now, wet doesn't necessarily mean raining. Damp, anything that has a little bit of moisture in the atmosphere will set this up. Washing cars, that'll do the same thing. You're adding water to your connector. Match the connector metal to the vehicle metal as far as you can. Now, obviously, that gets a little bit difficult if you have either exotic materials on the car, or if you're trying to find connectors made out of, for example, just non-plated steel. You don't tend to get just steel eyelets. They will be tin coated. So far as you can, try and match it. So you probably can't see that from there, but that is essentially what galvanic corrosion is. The electrons are being swapped from one material to the other. So one material is receiving the electrons, one material is giving up the electrons. When that happens, you get ions, and ions love to dissolve in things, specifically water. And what will happen is, over time, it will start to eat away at the metal, and what that metal is it doesn't sort of rust per se, it'll just dissolve into the rainwater and get washed off. Galvanic corrosion occurs because the dissimilar metals can receive and swap and donate the electrons respectively. So you almost make metal salts, and they just dissolve in the water and eventually disappear altogether. You'll see, and those of you who are familiar with sailing and boats, you have sacrificial anodes, which is that one on the left. And basically, that's the one that gives the electrons. So that will corrode first, and the theory is it saves the other material from corroding. It's a sound theory. It works for the most part, providing you keep up with it. However, as we all know with car maintenance, asking your garage to have a look at your sacrificial anodes is probably going to give them, and you, a little bit of a funny look. So, of course, yeah, just be aware of galvanic corrosion. There is a handy list. There's lots of lists out there on the internet, but this one is also handy. And this is the metals. So contact metal on the left, contact metal on the right. You can imagine that as bodywork metal on the left and whatever metal you're using for your earth strapping on the right. Green squares, good to go. Red squares, avoid. I won't remain on it too long. This will be available. Of course, this is also online. The link's on the right-hand side. Yeah, it's a bit of a sod actually. It's not what you'd expect. For instance, carbon steel and stainless steel isn't something that you want to put together, but you would expect that to be all right, as they're both base steels. You'll get that list. Usually when you buy things, they'll tell you what's in them as well. So connectors, eyelet crimps, my favourite. They're great, they work, you put a screw through them, you can solder to them. I typically put a star washer on there. That'll get through any oxidation or paint. So the star washer's on the back of the eyelet crimp, and that just basically bites through to the proper metalwork. You can get self-drilling, self-tapping screws. They will drill a hole and then tap themselves into the side of the bodywork. That's if you don't want to drill into metal. Get an impact driver, you put the screw in, it does it all for you. You don't have to muck around. That's an example of eyelet crimps. I'm sure you've all come across these. That's an example of an eyelet crimp set you want to avoid. If you see them like that and you get like 300, 200 pieces for a very, very low price, typically what you'll find, I say avoid, it's perfectly fine if you know what the caveat is. The metal on the crimp's only that far. So it's really easy just to crimp the plastic and not the metal, and then the wire just comes out. Usually the wire comes out when you've just got your hand round underneath the lip in a really awkward position lying on your back in the garage, and then the wire comes out. You have to do it all over again. But yeah, eyelet crimps. Fixings. So the reason why there's a cross through the flat washers, and I've kept the cross there, is because the flat washers don't really do anything for biting through paintwork. So when you have any metal, even if it's a bare metal, if it's been bare for a while, you've got an oxide layer on it. That's an insulator. Two conductors and insulator make a capacitor, and that ain't a good ground. Spring split washer is just nearly as terrible, but it will just about bite in. The ones that I recommend are the external tooth and the internal tooth. And you'll see the little teeth, and they stick up, if you imagine that being the flat, and they stick up like that. And as you screw it in, it physically scores into the metal and the paintwork. Not only that, but it also provides you some vibration resistance. If it's near the engine bay or you need some vibration resistance, I can definitely recommend the lower left section there, as they perform really, really well on vibration tests to hold in. NASA had a white paper, and there's a couple of videos out there. I can't remember off the top of my head what company did it, but they were testing them with load cells, and essentially, bottom left, absolutely superb. Top right, don't bother. And of course, you have some built into the nuts as well. So nylocks are also fantastic, giving you some vibration resistance. So once you've tightened it, it remains tight and it won't unscrew itself slowly. Self-drilling screws, fairly self-explanatory. The top section drills in, then it self-taps to give you some purchase, and then it clamps it together. They're a blessing, a curse, self-drilling screws. I very, very, very seldom use it. Mainly because of the first rule: if you can avoid drilling into bodywork, avoid drilling into bodywork. Little bit of a nomination there. Mag mounts. If you're not keeping the radio in the car the entire time, there's no point in doing any of this, to be honest, if you don't want to, if you're not comfortable with doing it, because you're not going to get many returns on it. Your mag mount, use the biggest mag mount you can. You see those mag mounts with the extra 3 magnets on it? Get those. The more surface area that magnet makes with the top of your vehicle, the better you're going to be. And I have had a couple of cases where somebody has bought a lovely HF antenna. It looks fantastic, and the mag mount is about the size of a biscuit. And it goes on top of the car, and the whole thing's flopping around like this. And because you have that tiny amount of ground coupling, start off on a higher frequency and it works fine, and then you just watch the SWR just suddenly peg the needle. Same thing. Bigger your mag mount, better your coupling's going to be. Can cause issues depending on the frequency. Also can cause you issues depending on the depth of paint, especially if your paint is starting to wear or it gets a little bit furry. It's not a great surface because it will slide around, which can cause a problem as well. It does change colour, yeah. It's really weird how it fades to paint. Yeah, those of you who've had a mag mount on for quite a while, or you've changed or got new cars, pull the mag mount off and you get like a really weird, perfect paint circle. That stands out far too much. Brillo, just Brillo over it and just scratched around. It's fine, blends right in. Ooh, that made some of you cringe. Depth of the paint, of course, affects ground coupling. So there's a big caveat to all of this, and some people do love vintage cars. And I know quite a lot of, I know at least one person who was in the Robin Reliant Club. And those of you who remember the Robin Reliant, none of this applies to the Robin Reliant because it's a fiberglass chassis and is therefore not conductive. So of course, again, with the mag mount, massive caveat, be aware, cars have more and more plastic on now than ever before. They've got more and more covers on now than ever before. A lot of them, like my own, have glass roofs, which makes it difficult to put a mag mount on. If you have no other place to put a mag mount and you really, really, really need to get out there, stick it in the middle of your bonnet. That's the biggest continuous piece of metal on the vehicle apart from the roof. And that'll do it. It won't be perfect, but it'll get you out for a bit. Oh, yeah, yeah, it goes without saying. Don't drive with it on. It's quite distracting having this in front of you as it's going, or when you stop and the whip starts cracking the top of the windscreen. But yeah, it can cause issues depending on the frequency. Get the biggest mag mounts you can find. But if it's just a temporary setup and you don't normally have a radio in the car, mag mount. That's what they're for. That's what they're designed for. They work great at doing it. If you really, really want to make sure that your antenna is grounded, you can either get a big eyelet or one of the fork connectors, unscrew your antenna ever so slightly, and check whether or not the screw that's going into the mag mount is ground. Typically it's not. Usually on the underside of the mag mount is the screw that holds the magnet in. Take that screw out, put a bit of wire or braid or coax on that, and then you can put it to a bit of metalwork on your car and get sort of the best of both worlds. Be aware that could also start a ground loop because you've got really nice conductive wire and then you've got some capacitive reactance. So just have a bit of an experiment there, but I have seen some people do that. I can't say whether or not it works because I've never tried it myself. Oh, it does work if it's the ground wire. Oh, smashing, yeah. 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 smashing stuff. Oh, okay, so it works. Yeah, you put some wire on mag mounts. You can do the same thing with HTs. Test. And the reason I say this again, you have a massive amount of computing power in cars now. Engine control units, the modern cars have body control units, and they talk to each other. But they don't do the same thing. One looks after your brakes, the other looks after your engine. It can be a nightmare. Your circuits, your lights will communicate on the CAN bus. Boot hatches, boot lids will communicate on the CAN bus. The one thing, and one of the major things to watch out for, and I haven't had any personal experience with this, but it is a remote possibility. Airbags. You essentially have an explosive contained within a nice bag, as the name sort of suggests. They go off roughly at the speed of sound. They are loud and they hurt. So when you're testing, there is a very, very, very remote possibility that the airbags may detonate. If that happens, something has gone very, 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 very wrong. Because the current induced to detonate the airbags, I don't think you get anywhere near that with the RF that'd be induced on the line. Typically, when that happens, is the body computer or the ECU, whichever's responsible for the airbags, I can't remember off the top of my head, has had interference, and the G sensors have told the ECU, or the ECU thinks the G sensors have been operated, and then it'll detonate the airbags. I've not had any first-hand accounts or second-hand accounts, and it's one of those things that floats around. It is a very, very remote possibility, like any other system, that can go wrong. The likelihood of it, terribly slim. So don't worry too much. But mainly for the testing is whenever you change your mobile setup, always test. As soon as you change something, things behave differently. You have different routes for the ground path. Test while stationary, because if you suddenly find out that your dashboard lights up or your speedo turns off, or your cruise control decides to try and accelerate you into something, it's not the greatest thing. Test whilst the engine's on. Get everything in the car running. Sit there with it idling. Key up. Have a test. Call CQ. See if anything changes. You don't want anything to change, but see if something changes. There are a lot of sensors on cars. The more cost-cutting procedures you have, the less shielding you use. The lower the quality of things is also used. So just be aware. Test whilst the engine's on. Test and monitor the instrument cluster. That's the one thing that's going to tell you what the car wants you to know. Usually, that involves the feedback that it gets from sensors. If you see your rev suddenly increase, or it suddenly thinks you're doing 50 miles an hour whilst you're in a car park, or the lights come on, sometimes you'll get a check engine light. That's always a bit of a fun one. Then you've got a problem. Typically, it's a grounding problem. And last, but of course no means least, what's behind? If you're drilling holes in things and putting screws in things and all the rest of it, what is behind? As you've seen my car outside, I modify vehicles as a bit of a hobby. A few friends have had four-wheel drive vehicles. When you buy them second-hand from a variety of, shall we say, marketplaces, people put things on because they look good and they don't think about, one, the functionality, but two, how they're actually attached for longevity. You'll be amazed. I have seen at least one person screw a reversing camera, and you've seen the vehicles with a spare tyre on the boot door, screwed a reversing camera straight into the spare tyre because that's the only place they could hold it. But you will get things like that. But as an example, just be careful what's behind it. You have fuel lines that will run through. Modern electric vehicles have got power lines running everywhere, and there's a lot of current in those. And of course, the last thing you want to do is drill into something and realise you can't open the driver's side door. Keyless entry systems, that's another great one. You can jam keyless entry systems if you're keying up. So if you are operating a talk-through, make sure your keyless entry system works, because if you're operating a talk-through and you close the door and a talk-through jams open, you can't get back into the car. And a lot of cars don't come with a key lock anymore, so that is a problem. But yeah, if you can't see what's behind the panel, don't drill into it. Could be anything behind there. Fuel lines, high voltages, something that's critical for the operating the vehicle, ABS lines. Yep. And then when you come to put the foot, then you pedal goes. Yeah. It's like stepping on a plum. Oops. Yep. Yeah. Brake lines. Yeah, that's a good one. Yeah, any hydraulic lines. Window washer lines is another one because they go through the boot and they take strange places to the pump lines for window washers. And sometimes you'll get it, someone will drill a light bar or something into the roof and they'll hit the window washer line that goes from the front of the car to the rear window. And you put your window washer on and it rains inside the cab. It's a very odd feeling. So yeah, don't drill if you don't know what's behind the panel. And that's it. So if anybody has any questions, by all means. Yeah, Anne. Salt will eat anything that it can. It's very, very good at eating anything it can. Typically, salt will accelerate any corrosion you get anywhere else in the country, so it'd be quicker. If you are living somewhere where you're likely to have a lot of salt spray, my suggestion is, like anything else with a walk around on a car or regular maintenance, just keep checking on things. Great product to use, at least in a pinch, that's nice and cheap, to cover connectors is Vaseline, petroleum jelly. You can get other things, you can get proper lana guard and stuff like that, but without going too far. Yeah, just make sure they're clean, dry as much as they can be. If you are connecting to things, just make sure it's shielded from spray. But yeah, no, salt will accelerate these things. Salt and electricity will absolutely turbocharge them, yeah, without a doubt. So it's one of those, just keep looking at it, observe it. If it looks like it's starting to corrode, take it out, have an assess. See if you can change where it's positioned. Absolutely.
The braided stuff. I had braided on my mag mount.
Yeah.
And I went to a car wash, got the car washed, and as I stood there, I thought, they look a different colour. It fit into the actual cars
Yeah. Yeah.
Car washes as well,
Surfactants are a bit of a dicey one as well because they'll change the surface tension of the water, and it will go even more strange places on there. But yeah, car washes is a good one.
I think I found that don't assume because it's metal and structural, it's ground.
Yes, yeah, also very true.
The roof bars on my
not grounded.
Absolute nightmare. They're structural. They're not good yet.
No. No.
Braid your roof bars.
Yep. Bond everything. Yeah. Bonnet, boot lid, both doors. If you're feeling particularly that way about it, doesn't make much of a difference. But yeah, petrol cap. But yeah, roof bars. Max has come up with a really good point. Roof bars are really difficult. Sorry, not really difficult. Really easy to assume that they're grounded, and a lot of the time they're not. So mine specifically, where the antenna mount is onto the roof bars, has a coax ground strip that goes back into the boot, and that also grounds the roof on there. But yeah, roof bars will clamp on, but they often have the rubber feet on, and the actual rails that run along the car. Sometimes you'll find that they're plastic.
No, aluminium.
Yeah, or Ali as well. Yeah.
The rock solid, but unfortunately, there's no.
They'll anodize them. Sometimes they'll anodize them, so the oxide layer, when it hits the paintwork on them, because they'll paint the car and then anodize the roof racks, and you do end up with that paint thing. But then again, you get that phenomena where you'll get into HD absolutely fine, and you do anything on HF and you peg the needle on the SWR. Yeah, it can be a bit of a nightmare. Manufacturers, different vehicle manufacturers have different ways of corrosion inhibition and manufacturing techniques. So you'll have two cars that look very, very similar and are completely different to try and ground out properly. Any other questions?
You know the roof things that we have on cars?
Yeah.
Well, I had a car and I think they put it on because
yeah, just to look to the style at the time. Right.
But I was able, because it was stuck on with
yeah.
That I was able to remove it. And lo and behold, there's a hole there.
Oh, nice. Okay, yeah, that's handy.
To use that.
Yeah.
And then I just moved the aerial thing back a
bit. Yeah.
So it's still there.
Nice.
Second hole. And then when I sold it, I just took it out.
And moved it back again. Yeah, no, it's a really good idea, is that, yeah.
Generally, towards the back of the car.
Yeah.
So, yes, I did have to get under the roof line, but it wasn't only like a...
Yeah, just a small bit.
So that's an option. If you want to permanently mount it, but don't want to do a hole.
Yeah, that's a really good idea, that, yeah.
For a boot-mounted installation,
Hmm.
would you consider screening the positive line and earthing it at one end in a modern car?
As in,
Thinking of RF on the positive DC line.
oh right, okay. You could, yeah. I've never really, personally, I've never had much issue with the DC positive ending up with some RF back on it. My suggestion, probably start simple and coil the DC line, make a bit of a choke on it. Try and keep the RF off that way.
And where would you connect the positive feature? Directly to the battery, or to the main feed in the twofold?
Depends on your setup. The recommendation I tend to have is always connect it via a fuse.
Oh, of course.
To now, it depends on how new your car is. The recommendation was to connect it to the positive of the battery. Modern cars have a current sensing system, so they'll change what voltage the alternator puts out depending on the load on the alternator, and they detect that away from the battery, which makes it even more difficult. So depending on your radio and depending on your vehicle, it's a case-by-case basis, typically. That's the difficulty of it. In mine, I've got a split charge system, so I have the battery that runs the radio and the boot, and I'm just connected to that via a fuse. And then there's a 40 amp breaker to the alternator directly on that battery. But there is a battery management system that's meant to be on there, and knowingly, I have just avoided that. But yeah, case by case basis, and different cars behave strangely as well when they're not expecting a load. Stop start vehicles, especially, are quite difficult when you're setting up radios on, because there's a lot that goes into monitoring battery health.
I mean, as you know, I've got more than one vehicle, and connection to the cigarette lighter socket gives you an or not.
It's a bad Absolutely, you are.
Between the negative side of your cigarette lighter,
yeah,
and your antenna cable.
Yeah, I always recommend ground through the chassis on the vehicle. Use the chassis as your ground as much as you can, which comes back to bond everything, because then you know the path to the battery is you've got a lot of grounding there to achieve. Cigarette lighters, if you take them out, they'll give you 10 amps, but if you take cigarette lighters out, all you've got on the ground for a cigarette lighter is a tiny bit of wire. That goes back to goodness knows where via whatever route. So you tend either to get RF back, or it just doesn't handle the current very well, at least the RF current from your radio. And depending on where the positive's coming from on the cigarette lighter, you're putting RF straight into your fuse board, which tends to then distribute it throughout a variety of different systems. The problem with grounding is you will always have an RF ground. You've just got to decide what path you want it to take, or one will be assigned for you, and it's not usually the greatest one from that one. So yeah, to come back to your question, case by case basis, it honestly depends on the vehicle and what setup that's in there. But again, comes down to sort of the shack management situation of, if you can fit ferrite beads on it, put a ferrite bead on it. There's not much else you can do without testing. I've known some modern vehicles be absolutely fine with 8900 jammed straight into the cigarette lighter and a mag mount stuck on a tiny stretch of metal by a glass roof, and no problem whatsoever. Oh, right, okay, yeah. If it works, stick with it. A more permanent solution, again, depends entirely on the vehicle. Mm.
HGVs.
Yeah, and Luton vans.
Pull the headlining down and use adhesive back foil underneath in a panel and stick it up underneath, and then bolt through.
Yeah, and attach to the foil layer.
And we've also used
roofing tape's good for that.
Copper strip, window strip.
Yes, yeah.
Window strip to create radials.
Yeah. Oh, nice. Okay, no, that's quite a good one. Yeah, they sell it as slug tape as well, don't they? Yeah. Yeah, aluminium back tape is good, and it works. It works rather well for ground. Oh, the reflective insulation. Yeah, that bubble wrap insulation stuff's metallic as well. That works quite nicely.
Silver on one side, adhesive on the other.
Yeah, yeah, it's good. Yeah, not sure how to do with a linear, but at least you won't have to turn your radiator on. Yeah. Any others? Questions? Everybody happy? Right. Thank you very much.
We really appreciate you taking the time to watch this video. Don't forget to check the video description where you'll find additional information about the video you've just watched, along with links to products used and to the Haddai's website. If you enjoyed this presentation, please feel free to hit that like button. Maybe you'd also consider subscribing and clicking the notification bell so we can let you know the next time we release another video. Thanks again for watching.